Hello, today we at 26 are proud to present to you our high optical output power coherent integrated optics that enable highly simplified metro and regional transport networks. At the recent European Conference on Optical Communications, 26 was awarded the ECOC Exhibition Industry Award for Most Innovative Product Optical Integration for the ICtrosa, or Integrated Coherent Transmit and Receive Optical Subassembly. This component is the industry's first implementation of the ICtrosa Type 2 as defined by the Optical Internetworking Forum, or OIF. It integrates all building blocks of a coherent optical frontend, together with the associated control circuitry, in a small package with simple digital management interface. The part contains built-in semiconductor optical amplifiers that deliver a high transmit output power of up to 0 dBm. The ICtrosa is based on 26's advanced indium phosphide photonic integration and enables 400 gig coherent transceivers in the QSFP-DD form factor that are compatible with ROADM-based metro and regional networks. This is key to allow wide-scale IP over DWDM deployments in carrier networks across the globe. The ICtrosa is the optical engine for high-performance digital coherent optics in the QSFP-DD pluggable form factor. It is easily integrated into the front of the QSFP-DD module, leaving plenty of space for the coherent digital signal processor behind it. If we look at the current landscape for 400 gig pluggable coherent optics, we can broadly identify three categories. First, there are the 400ZR modules that follow the OIF 400ZR implementation agreement, targeting point-to-point data center interconnect applications over relatively short distances. These modules come in a QSFP-DD or OSFP form factor, compatible with routers or switches. They support a single 400 gig Ethernet rate and have a low transmit output power of -10 dBm. The modules use a lower performance forward error correction code, optimized for low power dissipation, that results in a moderate receive OSNR tolerance. Chromatic dispersion compensation is also limited, so reaches do not go beyond 120 kilometers. The OpenZR Plus multi-source agreement, built upon the OIF 400ZR specifications, but targeted to extend the reach. The OpenZR Plus MSA added a higher performance forward error correction code that results in an enhanced receive OSNR tolerance, and extended the chromatic dispersion compensation to support reaches beyond 600 kilometers. The OpenZR Plus, however, maintained the QSFP-DD and OSFP form factor and did not fundamentally change the transmit optical specifications. So transmit output power is limited to -10 dBm. The Open ROADM MSA, on the other hand, targeted transceiver specifications that are compatible with colorless and directionless ROADMs widely deployed in metro and regional transport networks. Key parameters to ensure compatibility with colorless directionless ROADMs are a high transmit output power of up to 0 dBm and a high transmit in-band and out-of-band optical signal-to-noise ratio. Because of these tighter transmit requirements, the Open ROADM MSA assumed transceiver implementations would use a larger CFP2 form factor to leave room for additional components inside the transceiver, like an EDFA or a tunable optical filter. What the 26 ICtrosa allows you to do is essentially get the best of the OpenZR Plus and the Open ROADM worlds. It allows you to achieve a high transmit output power, 0 dBm, and a high transmit in-band and out-of-band optical signal-to-noise ratio in the smaller QSFP-DD or OSFP form factor. To understand why this matters, let's look at a typical ROADM network. Most of the traffic in today's ROADM networks is IP traffic, originating from a switch or a router. In order to connect a switch or a router into the ROADM optical layer, you typically use a transponder or muxponder. So the switch or router connects to the transponder or muxponder using client optics. And then the transponder has colored coherent interfaces that connect into the ROADM. These colored interfaces could, for example, be CFP2 DCO modules, or they could be discrete implementations. Now, if you can have the high transmit output power that the ROADM requires in the QSFP-DD form factor, you could plug your colored coherent optics directly into the switch or router and eliminate that intermediate box. It obviously gives you significant capex savings because you are removing that additional piece of equipment, and also you're removing the client transceivers that connect the two systems. But it also gives you significant operational expenditure savings. It reduces the amount of rack space that carriers need to rent. It reduces their electrical power consumption and lowers their cooling requirements. And just overall, it reduces the number of network elements that they need to plan, install, manage, and maintain. In summary, the 2.6 ICtrosa enables simplified metro and regional networks. The integrated coherent transmit and receive optical subassembly with advanced indium phosphide photonic integration is the optical engine for high transmit output power 400 gig coherent transceivers in QSFP-DD form factor that enable IP over DWDM in ROADM networks. This innovation will result in significant CapEx and OpEx savings for network operators.